Welcome back to Robominions.in AI interview preparation app. The topic of this video is topological sorting. Before tracing the code, I request you to watch this video on your laptop or a full size screen on your mobile phone in a horizontal view so that you can clearly trace the code along with me. If the code is not clearly visible on your mobile phone, then I strongly suggest you to watch this video on your laptop. The app I am using is Robominions.in AI interview preparation app. This app will give you total control over the code. By just clicking back and next button, you control the code and trace the code at every stage. And the app is available in the website robominions.in. Download the latest version here. And if you have Windows OS laptop, download for Windows. Now let's start tracing the topological sorting algorithm. So first we have hash include stdir.h. Then we have a macro hash define vertices 4. So V stands for vertices. There are 4 vertices in the graph. Then we have a void topological sorting function which is declared. Then we have a graph of the two-dimensional graph of 4 by 4. Let's see. So we have 0, 1. That is 0 to 1. There is a edge. Then we have 2 to 3. There is a edge. 3 to 1. There is a edge. So this is the graph. So 0 to 1, 2 to 3 and 3 to 1. So we need to find the topological sorted, or we need to find the topological order according to which we have to find from different nodes to reach 1. So what is the order we have to take? So now let's see. We have 2 arrays declared. In degree array which finds the degree of each node. We keep a track of that, and then we have a flag where we mark once we have visited the node. Then we have void main. So okay, before that in degree and flag both are both are right now garbage values. Okay, then we have a void. In the void we have a for loop where we go through each of the array element and initialize it to 0. So in degree, so 0, so I is 0 right now. So in degree array is made, the first index is made 0, flag of 0 is made 0, in degree of 1 is made 0, flag of 1 is made 0, and respectively. So finally I reaches 4, 4 less than 4 is false. So then we have a printf topological order is printed, and we call the function topological sorting. We go to the function void topological sorting. In that we have a for loop I equal to 0, I less than v. So 0 less than 4 is true. We go inside the for loop. We calculate the degree of each node. So we have j equal to 0, j less than v. So 0 less than 4 true. Then we calculate the in degree. So vertically we calculate for each, that is 0th node, we find the total degree here. So when we so I indicate the node 0, and we check whether there is any in the degree there is any edge which is towards the node 0. So we started with the 0. So 0 to 0 there is no edge, so nothing. Then we have then we check we have any edge from 1. So from 1 there is nothing. So 0 in degree plus graph of j1, that is 1, 0. So there is nothing. Then we increment j to 2. From 2 we don't have any edge towards the 0. Then we increment to 3. From 3 we don't have any edge towards 0. 4 less than 4 is false. So finally we have a 0. So in degree of that is inwards arrow degree of node 0 is 0. Then we increment I to 1. Again start from 1. We start from j equal to 0. We have for 1 we have 0, 1. So for 0, 1 we have from 0 to 1 we have a inwards edge. So that is equal to in degree of I is 1. So in degree of 1 plus, so 0, first initially it was, if I click back you can see initially it was 0. So then we calculate in degree of 1 equal to 0 plus graph of 0, 1. So graph of 0 comma 1, that is 0 plus 1, which is equal to 1. So in degree has been calculated to 1. So we have calculated this edge now. Then we increment j to 1. So j to 1. Then again in degree equal to, so in degree of 1 comma 1. So for 1 there is nothing, there is no edge from 1 to 1. Then j is incremented to 2. From 2 there is no edge. Then from 3 we have a edge. From 3 we have a edge. You can see 3 comma 1. So we equal to 1 plus 1 equal to 2. So in degree was 1 plus graph of 3 comma 1 is 1. So 1 plus 1 equal to 2. So in degree has been updated at the vertex 1. So we have updated it 2 because it has 2 inward edges. Okay, now so 4 less, so j is incremented to 4, 4 less than 4 is false. Now I is incremented to 2. We go to the second node. So node 2. So we check from 2 to from 0 there is any edge towards 2, there is none. From 1 we have 0. From 2 itself it is 0. From 3 it is 0. We are done of the for loop. Then we have I incremented to 3 now. For 3 we have one inwards edge coming from 2, right? So let's see. So 3 comma 0. So 0 comma 3. So 0 comma 3 we have 0. Then we have 1 comma 3. So from 1 towards 3 we don't have anything. Then we have from 2 to 3, that is 2 comma 3, there is a 1. So we add that. So we add that in degree. So 0 plus 1 equal to 1 has been appended to in degree of I. In degree of I is 3. I is 3. So we are done. So then now j is incremented to 4. 4 less than 4 is false. Now then again I is incremented to 4. We don't have any fourth, we have don't have any 4 numbered node. We only have 0, 1, 2, 3. So 4 less than 4 is false. Then we come to the for loop. Here we have a nested for loop where we iterate through the vertices again. So if we start from 0, I equal to 0, then k equal to 0. Then we have a if condition in degree of k. So k in degree of 0 is equal to 0, true, and flag of k, flag of 0 equal to 0 is true. True and true is true. It goes inside the if condition. So we look for lower degree value. So first we look for 0th degree. So we start from 0 degree. So in the topological ordering, we find the first we look for whichever node has 0 degrees. So right now 0 vertex has 0 degree. So we go inside the if condition. We print in the topological order. We first print 0 node. So node 0 has been added to the topological order, and then we mark it as flag 1, so that we indicate that it has been used. So 0 node has been marked 1. Then we have another for loop where we have j equal to 0, 0 less than 4 true. In that we go to the graph. 0 comma 0 is 0, so it is false. And then we come to 0 comma 1. So we have k is 0 and j is 1. So 0 1 is here in this position we have 1. 1 equal to 1 is true. So we go inside the if condition. So in degree of, as 0 is counted, in degree of 1 will be decremented. So you can see it has been decremented. When I go back, so the flag of 0th node has been marked, and the edge from 0 to 1 will be the degree will be reduced. When I click next, you can see from 0 we go to 1 and then we reduce the degree. So it has been reduced. Now again j is incremented to 2. 0 comma 2 we have nothing. 0 comma 3 we have nothing. Then we come out. 4 less than 4 is false. Come out of the for loop, and then we increment the k now. So k is incremented to 1. Okay. Now we go to if in degree of 1. So in degree of 1 is 1 and flag of 1 is 0. So false and true is false, so it doesn't go inside. K is incremented to 2 now. So in degree of 2, so we go to this node 2 now. So in degree of 2 is equal to 0, true, and flag of 2 is 0 because it is not yet visited. So now we go to the inside of the if condition, printf. So 2 is printed. So in the topological order we have done with 0, then we are going to 2 now, and we mark the flag of 2 as 1. So it has been marked. Now once 2 is done, we remove the degree which is to the 3. So we have to reduce the degree of 3, so that when we reduce the degree of 3, then we can, when it becomes 0, we can go to that node. So this is based on degree. So when we go to the node which has 0 degree, so that is the idea. So once we have done with the 0, so we reduce the degree of 1. Now once we are done with the 2, we are reducing the degree of 3, and then we again check if there is any 0 degrees. Okay, now we go to the for loop. Now we check 2 comma 0. 2 comma 0 is 0, so it doesn't go inside the if condition. 2 comma 1 is 0. 2 comma 2 is 0. J is incremented to 3 now. 2 comma 3, graph of 2 and 3 equal to 1 is true. So we go inside the if condition. J is 3, so in degree of 3 is decremented. Now it is 0. So now J is incremented to 4. 4 less than 4 is false. Now K is incremented to 1. So K is 3 now. So we go to the third node. So here we have in degree of 3. In degree of 3 was in previous iteration we decremented it, right? So now it has become 0 now because 2 is already done. Now we go to 3. So in degree of 3 equal to 0 is true. Flag of 3, we haven't marked anything for the flag of for vertex 3. So 3 equal to 0 is true. So we go inside the if condition, we print. So 3 is printed. Flag of 3 is marked 1 now. You can see flag as 3 is marked. And then we have from 3 to 1 we have an edge, right, towards 1. So that degree has to be reduced. So we check through the adjacency matrix in the graph, and wherever 3 comma 1 we find 1 from the edge 3 towards any of the node, we decrement the degree here down. So let's see, 3 comma 0, that is because we have K3 and J0. So 0 indicates the other nodes, and K indicates the 3 node. So K and 3 comma 0 is 0. We increment J to 1 now. 3 comma 1 is 1. So 3 comma 1 is 1. So graph of 3 1 is 1. 1 equal to 1 equal to 1 is true. Goes inside the if condition. We decrement the degree of 1. So in degree of J is 1. So it is decremented to 0. Okay. Now J is incremented to 2. 3 comma 2 is 0. J is incremented to 3. 3 comma 3 is 0. J is incremented to 4. 4 less than 4 is false. Okay. Now we increment K to 4. 4 less than 4 is false. Now we increment I to 1. Now again we start from 0 to 4. So again we start from, so we go to in degree of K. So for K, in degree of 0, for K is 0, right? In degree of 0 is 0, but flag is 1. So this fails, doesn't go inside the if condition. K is 1 now. So in degree of K, in degree of 1, that is in degree of 1 now is equal to 0. So right now it is 0 because we are done with 0, 2 and 3. 3 is also done, 0 is also done. So the degrees have been reduced. So only 1 is remaining. So that is true, and flag of 1 indicates that we haven't yet visited. So flag of 1 equal to 0 is also true. So it goes inside the if condition, we print the 1. So we have found the topological order for this graph 0, 2, 3, 1. Okay, now we mark the flag 1 and from 1 we see whether we have to reduce any degrees. So from 1 towards any node we check. So start from J equal to 0. So we have 1 comma 0 is 0, then we have 1 comma 1 is 0, when we have 1 comma 2 is 0, then we have 1 comma 3 is 0, so we found nothing. So 4 less than 4 is false, comes out of the for loop, comes out of the if condition. Now k is incremented to 2. Now we check, in degree of 2 is 0, but flag of 2 has already been visited and it's marked, so it has been done. So it is 1. So the if condition fails. K is incremented to 3 now. For 3, again we have in degree 0, but flag is already 1. It has been done. That is also false. K is incremented to 4 less than 4, false. Now I is incremented to 2 now. We check for I is incremented to 2. We go to the for loop again. Again we start from k equal to 0. Same story, k1. So all flags are 1 now. So all the if condition fails. 3, false, 4 less than 4. Now I is incremented to 3. Now again we start from k equal to 0. Goes to the in degree if condition. K is incremented to 1. If condition fails. K is incremented to 2. If condition fails. K is incremented to 3. If condition fails. K is incremented to 4. 4 less than 4 is false. Comes out. Now I is incremented to 4. 4 less than 4 is false. Comes out of the for loop. Comes out of the topological sorting function. So finally we have topological order 0, 2, 3, 1. Comes out of the main function. The time complexity of this algorithm is order of v square. And it is also can be order of v cube when it goes inside the, so when it is iterating, because there are 3 for loops, it can also be order of v cube. So and to trace the code, just like I have done step by step, to understand the concept of this code, you can use the app Robominions.in AI interview preparation app. The code of this algorithm is available in the code button here. You can run it on any online offline compilers of your wish. And to download the app, click on so go to website robominions.in, click on download latest version. The app is updated every 3 months with lots of new topics and bug fixes. Download for Windows OS here if you have Windows. See you guys in next video. Thank you. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.